In this video I'm going to talk to you a bit about simultaneous equations. And I'm going to talk to you a bit about why they're useful to start off with, so simultaneous equations. So why are they useful? So let's say that we have our axis. Oh, that's not very straight. Let me do that again. So we have our straight axis here, our axes. This is our x and this is our y, and we have two lines on them. So let's have a red line that goes like this, and we have a blue line that goes like, maybe like this. So these are supposed to be straight lines, by the way. I know they're not completely straight, but let's say that this is the line A, and red is going to be our line B, and I want to know where this point is, the point at which these two lines intersect. So let's say that the line A is that looks like to me like y equals, I don't know, let's call it 5. Y equals 5. And our line B is going to be y equals maybe 2x plus 2. So y equals 2x plus 2. So I want to know where these two lines collide here, where they intersect, like that. So what I'm going to do is say, right, these two have to be kind of equal to each other in order for these two to be the same. I need to find this point here where both of these are the same. So what I'm going to do is I'm going to say, well, y is here and y is also here. So what I can do with these equations is I can say, right, we have y equals 5, or 5 equals y, which is exactly the same, which is equal to this y here, which is also equal to 2x plus 2. 2x plus 2 there. And then what I can say is that I have 5 over here equal to 2x plus 2 over here. They're all equal, these things are equal. So we have 5 equals 2x plus 2, and then what I can do is, because there's no y in this equation anymore, I can get a value for x. So let's do that. Let's take away 2 from both sides. Let's do it in another color, I think. So take away 2 from both sides, and we're going to get 3 equals 2x. And then if we divide both sides by 2, we get x is equal to 3 over 2, or 1.5 if you prefer. So that's what we have as our x value. So now what do we have as our y value? Well, what we can do is we can say we know what x is. Let's put x in here. Let's put 3 over 2 in there and get a y value out of that. And yes, you can do that, and that's all very well. But if we look at the first equation, y is always 5 regardless of what's going on with x. Y is always going to be 5. So we know that this point of intersection, the x value, our x value is going to be 3 over 2, and our y value is going to be 5, because y is always 5 regardless of what x is. So our point of intersection there is going to be 3 over 2, or 1.5, 5. That is our point of intersection there. So let's try it with a more difficult one. I think you can handle a bit of a more difficult one. So let's say that I have the line, I don't know, minus 3y minus 7x plus 3 is equal to 0, and I have another line, I don't know, let's have it as y plus 4x is equal to 9. So I have these two lines here, and I can't really do the same as what I did last time. I can't just make the two y's equal to each other because I don't have the two y's in isolation. So what I have to do is somehow manipulate these so that I get a kind of an x-less or a y-less equation. So I just have x or y on their own in one of these equations. So what I'm going to do is I'm going to say, right, this purple equation here has 1y in it. This green one has minus 3y. So I'm going to times this whole lot, this whole thing here, by 3. That whole lot by 3. And what I'm going to get at the end of that is I'm going to get 3y plus 12x is going to be equal to 27. That's what that is going to be equal to. And then what I can do is I'm going to say I'm going to add this green one. So this green one here, I'm going to add that to this one here, and in doing that, what I've done is I have a 3y here, which when added to a minus 3y here is going to give me 0. So I just have x values in my equation. So let's add those two equations together. This is perfectly legitimate. You can add equations together. So we can have our minus 3y plus 3y is going to be 0, so let's put that in 0. Then minus 7x plus 12x, that's going to be a plus 5x. And then 3 plus, well, we've got 3 plus nothing there, so we've got plus 3 there, and then 0 there, plus 27, so that equals 27. So then what we have is a 5x plus 3 equals 27. So let's take 3. Let's take away 3 from both sides. So we get a 5x is equal to 27 take away 3 is going to be 24. And then we haven't really got a nice number here, but we've got x is going to be equal to 24 over 5. So we have our x value for where these two lines, where they intersect. That's the whole objective of this thing. So where do these two intersect? Well, the x value is going to be 24 over 5. So then we can put that into our second equation. It looks like it's going to be easier than timesing it by minus 7. So let's times that by 4. So we're going to get, let's put that in there, we're going to get y plus 4 times by 24 over 5 is going to be equal to 9. Be equal to 9. So let's do that. So what is 4 times by 24? That is going to be 96, I think. 96. If I'm wrong, comment on it, let me know. But I think that's 96. So we're going to have y plus 96 over 5. Oh, I should have put an x in here. That was a mistake. This is an x in here. So 96 over 5 amounts of x is going to be equal to 9 there. No, I was right before. No, ignore that last bit. There is no x in there. So y plus 96 over 5 is going to be equal to, then let's put this 9 in terms that we can use to add or subtract from this over 5. So we'll put it into 45 over 5. And then what we can do is take away 96 over 5 from both sides. So let's do that. Let's take away 96 from both sides. And then what we're going to end up with is y is going to be equal to, that is minus, let me get this right, minus 51 over 5, I believe. Minus 51 over 5. So we have our x coordinate, we have our y coordinate, so the point of intersection, as long as I've made no arithmetic mistakes, is 24 over 5 minus 51 over 5. So that is more difficult than anything you will get in an exam, because I picked those numbers at random and I made it quite difficult for myself. That is way more difficult than you'll get in an exam, so if you followed that, well done, you'll be fine.